Today we will be talking about solving inequalities in one variable. The learning target is I can solve and graph inequalities. So we've already discussed just solving regular inequalities when you have an x is less than or greater than or less than or equal to or greater than or equal to, and how to graph that on a number line. Well, today we're going to talk about two special cases, and that's when the x's go away. So you're going to notice that it's very similar to solving an equation, but this time it will be with inequalities. So example 3 is the one that we're going to go over. Understand inequalities with infinitely many or no solutions. So in example 3, it's a regular inequality. So I'm going to rewrite it on the side. So the first thing you want to do is to distribute, because you want to get rid of that parenthesis. So we got negative 6x. Be careful here, negative 3 times negative 5 is a positive 15, is greater than negative 6x plus 9. Now, notice that I multiplied by a negative, and I did not switch the inequality symbol. The reason why I did not multiply by a negative to both sides. Now, that's key. If you multiply by a negative to both the left and the right, then that greater than would become less than. But since I just distributed it on the left, we're fine. It stays a greater than symbol. So I'm going to draw my wall, and I personally like to get the variables to the left first. So I'm going to undo that minus 6x with a plus 6x. And then you're going to notice something. The 6x's cross out, and then we're left with a statement. 15 is greater than 9. So that's just, it's true. 15 is greater than 9. So that leads us to the infinitely many solutions. The same type of problem that we saw when we solved equations. So they like to show their work horizontally, which is fine. And then they got 15 is greater than 9 as well. So the original inequality is equivalent to 15 is greater than 9, which is a true statement. So you can show that this inequality is true for any value of x. So all real numbers, and you can put that too. So it's all real numbers. Our answer. So if I plug in 10 into x on both sides, then we're good to go. It's still going to be a true statement. If I plug in negative 2.8, it's going to get you a true statement. Now let's remind ourselves what happens if the x's cancel out and you get a false statement. So we have the 4x minus 5 is less than 2 parentheses 2x minus 3. So once again, we want the parentheses gone. So I'm just going to rewrite everything. So then we have 4x and then minus 6. So it's really important for you to actually show me these steps. I need to see the inverse operation. So then we're going to minus 4x on both sides. Now this is negative 5 is less than negative 6. That's actually a false statement. Negative 5 is bigger. And I know that seems weird because it's a negative. But think about it. I much rather owe somebody $5 than $6. So that's a false statement. So that leads us to a no solution. That means no matter what x you choose, whether it's at 10 or negative 2.7, you're never going to get a true statement. So there is no x that works for this. So since it results in a false statement, any value of x you substitute into the original inequality will also be a false statement. So this inequality has no solution. Now what I would like you to do, and you can write this down, and then this assignment will be in your online Envision kind of like an assignment, so you can check your answer. You can just type it in. So the first problem you are to do is negative 2, parentheses 4x minus 2 is less than negative 8x plus 4. And then for part B, negative 6x minus 5 is less than negative 3 times the quantity 2x plus 1. So this is where you're going to hit pause. All right, so I'm just going to do negative 8x plus 4 is less than negative 8x plus 4. So some of you guys like to stop here. If you stop here and don't show me work, you need to explain why this is going to be infinitely many. So you'll have to write a sentence. Some of you guys got marked down on a quiz before, so just be careful. I just like to show work. And then this actually, you have to be very careful, is not infinitely many solutions. The reason why 4 is not less than 4. So I was mistaken. You have to be careful. Inequalities is not exactly like equations. So in this one, it leads to a false statement. So you do have to go and do the work entirely. Now, if there was an equal sign under there, then yeah, that would be fine. But it's not. It's just less than. So let's see. So this inequality has no solution. So you cannot stop and say, oh, the same is on the left and the right, because at the end of the day, this inequality is going to lead us to the answer. So 4 is not less than 4. It's the same number. So you just have to be very careful there. All right, negative 6x minus 5 is less than negative 6x minus 3. Once again, you can't stop and look at this. You need to actually solve it. I need to see balanced. So then I have negative 5 is less than negative 3. And negative 5 is less than negative 3, because I have less money if I owe somebody $5 than if I owe them 3. So the answer will be all real solutions. Let's check. Okay. So make sure that you go through the motions and you solve the inequality, and then make sure that you read it out loud to you, or to yourself rather, because that will tell you if it's a true or a false statement.